This is lesson 12.8, Congruent and Similar Solids. Your objectives are to identify congruent or similar solids and to use properties of similar solids. Determine whether the pair of solids is similar, congruent, or neither. If the solids are similar, state the scale factor. In order to determine if these solids are similar, we need to set up proportions with their matching parts. So, on the left, we have a height of 8. That corresponds with the height of the cone on the right, which is 24. The radius of the cone on the left is 6. That matches the radius of the cone on the right, which is 18. If those fractions are equal, then the two cones are similar. Well, both of those reduce to 1/3. Which means that the two cones are similar. So they are similar because their corresponding parts are proportional, and the scale factor is this reduced fraction of 1/3. So match their corresponding parts. Make sure your fractions are organized. I did left over right for the height, and then left over right for the radius. If they're proportional, they're similar. If they're not, then they're not similar. For this one, we have two cylinders. Let's compare their corresponding parts. The radius on the left-hand cylinder is 5, and the radius on the right-hand cylinder, since the diameter is 10, the radius is also 5, so 5 over 5. And we'll compare that to the heights. The height of the cylinder on the left is 12. The height of the cylinder on the right is 24. If those reduce to the same thing, they're similar. 5/5 is 1. 12/24 is 1/2. Those are not proportional, so they are not similar. They are neither. If the corresponding parts are not proportional, it is neither. For these two prisms, let's check the corresponding parts. The height of 1 matches the height of 1. This distance of 5 is the same as this distance of 5. The height of the trapezoid base is 4, and that one is 4. And this base of the trapezoid is 3, and this base of the trapezoid is 3. Each one of those reduces to 1. And when the scale factor is 1, then the two solids are congruent. So these are congruent. The exact same shape and the exact same size, and all of the ratios of the parts reduced to 1. Here we have two rectangular prisms. This 2 on the left matches 1.5 on the right. This 5 matches 10. And this other 5 matches the other 10. Well, 2 over 1.5 is about 1.3. 5/10 is half, and 5/10 is half again. Two of them match, but not all three. So since the corresponding parts are not all proportional, this is neither. You have to have all of them match. Two cubes have a surface area of 72 square feet and 98 square feet. What is the ratio of the volume of the small cube to the volume of the large cube? Well, you have to remember that when you're talking about single dimensions, like a side, then your ratio is just x over y. When you're talking about area, which is 2 dimensions, your ratio will be x squared over y squared. And when it's volume, your ratio will be x cubed over y cubed. The numbers we have right now are for area, which is 72 over 98. That's going to correspond with x squared over y squared. I need to find out what x and y are, which will take me back to the original ratio. And once I get x and y, I will then cube each of those numbers to take me to the finish of the volume ratio. So since x squared over y squared is equal to 72 over 98, I can square root each side. So my xy fraction actually equals 6/7. To get 6/7, 72 over 98 reduces to 36 over 49, and then the square root of 36 is 6, and the square root of 49 is 7. Now for volume, I need to cube each number. 6 cubed over 7 cubed. So my volume ratio is 216 over 343. Make sure you pay attention to the dimension you're in, and then convert it properly. Number 6, 2 similar ice cream cones are made of a half sphere on top and a cone on bottom. They have radii of 1 inch and 1.75 inches respectively. What is the ratio of the volume of the small ice cream cone to the volume of the large ice cream cone? Round to the nearest tenth. Well, the radii are single dimensions. One of them is 1 and one of them is 1.75. I need to take that to volume, so I need to cube each of those numbers. That gives me 1 over 5.359, and then to round that to the nearest tenth, it's approximately 0.2. So remember what happened. We had single dimensions for the radii. I had to cube that to get to volume. Because remember, sides are single dimension, areas are squared, and volume is cubed.